Yo, in this video, you and me will build a tool that solves two very important problems when working with APIs. And I want to show you those problems by example. To start, let's imagine that your API does three things, right? It does expensive calculation 1, it does expensive calculation 2, and lastly, it saves the result of both expensive calculations in a database. Now, what happens if expensive calculation 1 is successful, but expensive calculation 2 fails? If you had this as a single API file, then you would have to handle retries on the client and go through expensive calculation 1 again, even though it was successful, and do the second one again and then write to database, right? That's pretty inefficient because you need to repeat steps that previously worked. And now comes problem 2, right? All of the above, expensive calculations and writing to database, can only, at least in serverless environments depending where you deploy it, like on Vercel, take a maximum of 10 seconds, for example, on the free plan, right? You have a limit on how long your function can run. And if it runs longer, it automatically fails. That is really bad, because what if your function takes like on average 9 seconds, and sometimes it takes a bit longer because the database takes a bit longer or the calculation takes a bit longer? It doesn't really matter, right? All you have to do is kind of pray that it works, and praying is probably not the best way to write good software. The solution we are going to write in this video solves both of those problems. It lets you define certain steps, as many as you want, by the way, as a Next.js endpoint we're going to use as an example, and each step is a separate HTTP function that can now run up to 10 seconds, so you can split the entire workload for basically infinite runtime. And if any step fails, let's say step 2 fails, for example, we don't need to rerun step 1. Only the one that failed needs to be rerun, and that's gonna be done automatically with a retry strategy, as you're gonna see later in this video. So that makes for a super robust workflow. And the cherry on top, it's fully type safe. You get access to the results from step 1 in step 2 completely with TypeScript in mind, right? Whatever step 1 returns, you get access to in step 2. It's a beautiful abstraction on top of Next.js route handlers. No more timeout problems. It's super efficient because you only run the steps that actually fail again, and the result are extremely robust API calls. It's a nice way of writing your API that you're gonna learn in this video. So let's get started. Okay, so before we code anything, let's take a look at how this works under the hood, right? Why I really like how this works. So basically, we are in a basic Next.js API route, absolutely nothing special, right? Any kind of route.ts that you can create in Next. And inside of here, now comes the cool part, this workflow right here. We simply export a const post. So this is going to handle post requests to this API route. And you can see right here, we are creating something called a workflow, which we get access to a step right here. Trust me, we're going to get there. Before we do that, where does the workflow come from? Well, that's what we're going to do in this video. I've already published this as like an NPM package just to try if this works. But normally this will come from a file that we're going to create right now together. And all this takes is like one QStash token. And if you don't know what QStash is, let me show you. So I work at a company called Upstash, and we have a thing that's called QStash. Let's say upstash QStash. There we go. And it's basically like, let me show you what it does. It's an HTTP-based messaging and scheduling solution designed for, well, whatever, right? Basically, it's like an advanced cron job kind of. You can handle background jobs and schedules. It has like parallelism, automatic retries, and so on. It's basically perfect for this use case that we have right here, because each of the steps, let's take a look at the actual code. Each of the steps that we create, which are basically separate tasks, right, that could exceed the Vercel function timeout of 10 seconds if you're on the free plan, right? These have automatic retries, which means if any step fails, right, this one or this one, let's say the first one is successful, right, we basically just await a promise that returns a name of John, right? So imagine this was any API call or whatever, it doesn't really matter. We're just mocking it right here. For example, also AI, that could be. But now the second step fails. What happens? Well, in normal Next.js, if this was any route, you would have to run the entire route again and handle retries on the client, right? That's not really ideal. What happens in this code right here is that when step 0 is successful and step 1 fails, only step 1 is going to be retried with an exponential backoff automatically, which means the result from step 1 will still be there, right? We don't have to run this step again, only the one that failed. And once it has then resolved successfully, only then are the next steps called, or the final step where we save this to the database, for example. And the cool thing is this is fully type safe. Whatever we return from the previous step, we get access to fully type safe in the next step. For example, if we had like a country right here and it was the USA, right? So we have name and country. Then of course in the step 2 we can access that data. And how this works under the hood is so cool, right? We don't have to run any steps more than we really need to. The results of each step are automatically passed to the next one with retries and so on. So it makes for a very, very robust workflow engine that also allows us to go way beyond the time of the default timeout, right? Now this step can take 10 seconds and this one can take 10 seconds as well. And each step can now take 10 seconds, and you're going to see how and why here in a second when we get to the implementation. So we have 3 steps in this kind of scenario right here, which means now our timeout for this entire thing would be 30 seconds with automatic retries, which is so much better than 10 seconds, and we have to handle retries ourselves and then run all the steps again if anything fails in the entire process, right? This just makes for a super, super nice workflow engine. So let's go ahead and implement that together. So let's start from scratch, right? Let's implement this from the absolute beginning. Let's navigate into our Next.js API folder. This is where we define our API paths. And you can see what I called my folder. It's called No More Timeouts, and that's exactly what it does, right? And we're gonna create a new folder right here. The name that we give this folder is actually gonna end up in the URL. So let's say, for example, let's just call it workflow. I think that's the easiest. And then inside of here, we're gonna create a route.ts. There we go. And if we now wanted to call this API route, that would be under, let's just add that as a comment, HTTP localhost, and that needs to be /3000, which is the default port /API/workflow, right? Because what we name this folder, workflow, actually ends up in the URL versus the route.ts does not. That just defines how we want to handle a request to this API endpoint, right? And of course, what we're gonna write here is gonna work in production as well as locally, everywhere, right? This will work perfectly. So let's get a very basic implementation going here. So normally how you define a API route in Next.js is by saying export const. So as a named export, you export a const, let's call it post, for example, and this will be an arrow function, right? It doesn't really matter if we define it as a const or as a actual function, as long as you give a named export of the HTTP verb. The logic in here is now going to handle API requests to this API route, right? So if you made a post request to this API endpoint right here, this function is going to handle that. And basically what we want to do is to abstract this logic, the post logic, into our own file so we can handle the automatic retries and the type safety and so on. So an API that would be useful to us would be something like this, right? Where we export a const and then we simply destructure the post from our then abstracted implementation, and that is going to be equal to a workflow dot, and let's call it create workflow. Now, of course, none of this exists yet. We're just kind of sketching out how the API should look that we want to interact with. And that's literally how I always go about this as well, right? I just kind of write how I want the API to look without anything actually existing, and only then go about implementing the actual API, right? So basically, the create workflow will give us access to a callback function, and in here we can now define the steps that we want. And before we get to the actual step part where we create the individual steps, let's not worry about that yet. Let's implement the workflow first. And I'm just gonna do it inside of the same file as the workflow API route. You can do this basically wherever you want, it doesn't really matter. And I'm gonna call this core.ts, but again, where you do this and the naming of the file, it really just doesn't matter. So the very basic idea is, how do we get this workflow in the first place? And there's 2 approaches we could use for this. Either this could be functional, or we could also go for an object-oriented approach. And I think the object-oriented actually works a bit better for this. And because if you've ever written any kind of SDK, it does make more sense to do this as a class. So we're gonna say export class, and let's name this workflow. And by the way, if you've never worked with a class before, don't worry, we're gonna do all step by step together. It really isn't going to be hard. Now, okay, exporting this class already allows us to now use it in our route.ts, right? So we can already get this at least. So we have the name defined. Let's call this const workflow, and that's gonna be equal to a new workflow that we import from the ./core, right? So from right here. And as long as we invoke that, we're good. Now the error is somewhere else. It's on the create workflow. Property create workflow doesn't exist on type workflow. Well, of course, because there is no function on our class that handles this create workflow. So let's create it. Let's give this class a function. Let's call it create workflow. And this is going to be equal to just an arrow function for now. We can worry about all the logic later. And as long as we have that, you can see, okay, the error is gone here. Now the error is somewhere else. And it's on the callback function now that we get from the create workflow. And it also is on the post, because there is no post method that is exported by our workflow class either, by this create workflow, right? So basically what we're expecting from our API route here is to export a post from the create workflow function. And we can already do this just to kind of get rid of the error, right? Let's define a post function. This is going to handle the actual API logic inside of our API route, right? That we're simply exporting and reusing from right here. And as long as we now return that post as a named kind of export, I guess you could call it, or named return, we can already see that now the post is defined. And what happens in this post is going to be exactly the logic that is executed when this API route is called. That's going to happen inside right here. And now as for the create workflow, this is still giving us an error because it doesn't know what the callback function is for, right? So basically what we're saying here is that the create workflow expects a callback function. And let's just call this the setup step, for example. And this is going to be nothing more than a function that returns void, right? And just like that, just by defining this callback function that the create workflow takes, the complaint is gone, right? And if we now try to put the step in here, now the error is back, right? Step is declared, but its value is never read. And much more importantly, the target signature provides too few arguments, expected one or more, but got 0. So essentially what TypeScript is saying is, well, I don't know what this step is and I don't know the signature of it because we haven't defined it. So what we're trying to do is get something from inside the callback function and we're calling it step, but that doesn't really exist. So let's create it, right? Let's name this the step and let's also give it a type of step and define that interface for each step. So basically, let's define it. Let's create an interface and call it step. And we're going to worry about like properly typing this out to make everything type safe here in a moment, right? Because as you remember in the beginning, the result from one step was then passed to the next, which I think is so cool. We're going to do that, right? But first, let's just create the create function. So what we want to do is to be able to call something like step.create, right? And then here we now define the logic of this first step that we have just created. And in order to make that work with TypeScript, we still need to define what the create function really is. And all it is like it's a callback function that takes an action, right? So whatever the user defines inside of here, so that's going to be a callback function, right? This is going to be the action part, what's actually executed inside of the step. And that will be of type, well, it's also just going to be a function that returns void, right? Or basically anything, whatever the user returns, that's what we're going to make type safe here in a moment. And it will simply return another step, right? That's the interesting part. This is how we achieve full type safety later on. Or actually, let's do it right now. I think it makes sense to do it right now. So how a step works, right? We have an input and we have an output. Whatever we return, for example, name John from a step is going to be the output. And whatever we receive in the callback function is going to be the input right here, right? Currently, we don't know what the input is because we haven't made it type safe yet, right? But what we care about is that the input is defined by the previous step or any at the very beginning, right? Because it's the first step. There is no initial input. And the output is then the input for the next step, right? So if we have two steps, comma separated, of course, the output is going to be the input for the next step. And telling TypeScript about this is actually not very hard. How this will work for each step is that we basically receive the input as something called a generic. A generic, you can imagine it like a placeholder, right? This is going to be defined at runtime when you call this API with your actual data. So for TypeScript, all TypeScript cares about is that this is a placeholder. And we can define this iGeneric by making it the return value of our callback function. For example, let's call this the previous result that's going to get passed into this callback function. And we're going to make it the awaited iGeneric, right? So whatever we get inside of the callback function as the previous result, we are assigning the iGeneric that value and the awaited value of it. So all the awaited does is when we mark this function as asynchronous, everything is still gonna work, right? This can definitely be an asynchronous function, and we're just gonna use the awaited value in that case, but it changes nothing if the function is not asynchronous. In that case, same thing, right? So it's just nice to have here. And now probably the most important part here is the output, right? What is the output? Basically, the output is whatever the action that gets passed into here returns, right? The return statement of, for example, name John is gonna be this one right here. It's not going to be void, but let's call it, for example, O for output. That's what I call it at least. And to receive that generic or to assign it, we can pass it right here at the very beginning of our callback function. So all we're saying is that the O, that's the output, is going to be assigned to the O generic, which we can now use as the input for the next step, right? That's the magic. We can simply pass in the O generic, the output of this step, into the input of the next, right? So the output of step 1 or step 0, I guess, wherever you want to start the index, is gonna be the input of step 2, of the next step that's coming, right? That's why we use the output as the input. We're calling the same step interface, but now with the output as the input, and so on. That's exactly how we achieve this type safety that is so nice to work with. And of course, initially, we don't have any data, right? Because we expect an input generic on our step now, we also need to define what the first step will be. And in our case, let's just leave it as any, right? We don't know what you will use as the input for the very first step. That could basically be anything, and we don't really care about it. Great, so we've done really, really important work on the type level stuff, but what we haven't done yet is the runtime level stuff, right? What should happen if a user inputs some stuff into their step.create? This logic right here, whatever happens here, should actually be run on the backend, right? And currently we've defined the types for it, but we don't really know or we're not actually executing the logic that is in each step. So let's do that. Let's say const step, and we already have the type for the step, right? This is going to be step, and that's put in the any as a generic because this is going to be the first step, the initial step. And therefore, again, we don't really know or care about the type because the rest is still going to be type safe. And of course, because we've already typed this out, this now expects a create function just like so. This is also gonna be an arrow function, just like so, right? But it's not gonna be any arrow function. This also receives something, and let's call it the action that this receives. So basically the user-defined behavior, basically whatever code you have inside of the step.create, that's going to be the action we have right here. And of course, that's also going to be a callback function. And let's say it returns void for now. Why are we getting an error? Basically, right, we could read the entire TypeScript error right here, but we already kind of know why this is throwing an error, or at least a TypeScript error, right? Because we are expected to return a step from each create function. And currently we're not returning anything from the create function, right? So in our case, let's simply return the step as the step. And now we want to pass the output generic in here. Now this output generic doesn't really exist yet, but it's going to be the exact same logic as above. Basically, the create function, let's define any generic, right? Again, this is just a TypeScript placeholder. TypeScript doesn't really know what this is, but we can assign it. We can tell TypeScript what this will be in each different function. So this is nothing else than whatever the user action returns, right? So just as before, whatever you return from the create function, in our case name and then string, right? In this case it would be John, but any string would now be assigned to this O generic, because we're telling TypeScript whatever the return value is, the O, that's what we're putting the generic to. So in our case, for example, this would be name string, as I just mentioned, because that's what we're returning from the user function, right? And same thing for the input, right? This is the action. The action gets the input, whatever the user puts in here, right? This is going to be a callback function. This is going to be the input to that particular step, whichever one you're on. So we can give it the generic, but we haven't assigned the value to that generic yet. So let's do it. Let's call it the previous result, and that's going to be of type I. That's going to be our input that we're now assigning to this generic. Great. And if we now go over into our route.ts and kind of hover over this, we can see the first input is going to be any, because that's what we typed it as, right? But if we hover over the second, oh, that doesn't work yet. Hey, so this is me editing Josh really quick, and the reason this doesn't work, and I'll only find this out later in the video, is because I accidentally invoked multiple step.create. You can see those two right here, and there should only be one step.create, and then only .create after that, not step.create again. And if you chain the .create without the additional step in front, then it will actually already work. I'm gonna find out a bit later. Perfect. Next up, you'll notice, and we can get rid of the example from earlier. Next up, you'll notice that the action, and that's gonna be like the actual logic for each step that's gonna happen in the callback function for each create step, that is actually not being executed now, right? So we're creating our step, but that won't actually do anything, and because we're not executing the action anywhere. And the way we're gonna do this is, first off, we want to save the actions inside of the class, right? So that later on, each action can be executed, and that's the secret to having this run in separate instantiations of serverless functions. So basically we get 10 seconds for each of these because we're running each as a separate HTTP request in the background, right? And in order to be able to do that, we need to save the actions somewhere. And that's gonna be inside of the steps, let's call it. And this is nothing else than a function array that we're gonna default to an empty array. So this is gonna contain all the steps that the user, or you in your case, have defined right here. So this could be 3, 4, 5, whatever. Right, we save all of them inside of this steps array right here, inside of our workflow. And in order to save the actual action, once we initialize it in our route, we can simply push it to this steps that we're keeping track of, right? We can simply say this.steps.push. And by the way, this just simply refers to this instantiation of the workflow class. Like, for example, this object right here that we get back is gonna be the this that I mean, yeah, it's probably the most confusing JavaScript keyword ever because it's literally named this, but it basically refers to this instantiation of that one class, right? It's gonna be this object right here. That's why it's named this, but I also understand why that naming could be like really confusing, right? But basically, we're pushing that into this specific instance of the object that we created using the new workflow right here. So into this, you know, I really hope that makes sense. And we're gonna push in the action into here. So whatever the user defined for that specific step that we're on, we're now saving that in an array, which also means that now for each post request that is made to this endpoint, we can now find the action that this user wants to execute for that specific step, right? Because if you remember, the post logic that we handle right here, the post function, is going to be exactly what we're going to execute in our main HTTP route, right? Great. So what this now means is that we already expect full type safety, right? Because we've already done all the work on the type level stuff. And if we hover over that's any, oh, because, okay, yeah, that's not what we should do. We shouldn't create a new step like this, right? We're not going to say step.create for each step, but we can simply chain the create function to that first step that we are creating right here, right? So we have one step and then we're creating a bunch of them by chaining the create function together. And now we expect full type safety, right? We have any for the first kind of invocation, and because we don't know what data the user will pass in here, how would we, right? But for all these subsequent ones, we now, beautiful, get the name that we're returning from here, or if we return something like the age of 25, in that case, the age of number would be expected as the input for the second function. The third function would then expect the name string because that's what we're returning from the second function, and so on. So always the return value from the like prior step will be the input value for the next step, and so on and so on. I think you get the idea, right? So we get full type safety across the board on all the steps. Beautiful. And now let's just implement the actual logic that should happen when this HTTP route is called. Because the fact is that this HTTP route is going to be called the exact same every time. And it's our job to tell which of the steps do we want to run on this specific invocation, right? But I mean, it maybe sounds a bit complicated, but it really isn't. So what we're gonna do, let's take a look at this like just conceptually, and that's just zoomed in way too much. There we go. Just conceptually, right? How this is gonna work is the first, well, basically this is gonna work through a step parameter that we're simply gonna pass in the URL, right? So for example, step is gonna be equal to 0. However, in the first invocation, when the user calls this function, the step is gonna be undefined. It's not gonna be passed because the user is gonna call the HTTP route like this, right? Localhost 3000 /API /workflow. That's what we're in, right? If you call this route, that's going to be the first API call to set up all the steps, right? And what we're going to do is basically we're going to use qstash, so the tool that's going to do all the automatic retries and so on, and call it with the step is equal to 0, right? So qstash will call this endpoint for us, and if it fails, it will retry with like exponential backoff, which is beautiful. If nothing goes wrong, then we schedule step 1, right? So if we're done with step 0, then the next step, we're just simply gonna increment the step right here. And by the way, this needs to be like a question mark to be proper parameter. There we go. And then we're gonna execute the step 1 and step 2 and so on until we're done with all the steps, right? So basically, we are invoking this endpoint a couple of times, to be more specific, once for each step in our entire workflow. And that's how we achieve the 10-second now for each, right? So we massively increase the timeout that we have for each function to run. And if you're doing like extreme processing in here, right, you need a lot of power. It takes very long. Let's say you were processing 1 million CSV rows, right? What you could do is process like the first 500,000 in the first step, then process the next 500,000 in the second step. If anything goes wrong, you get all the retries in the world without having to do all the work, right? If this fails, you don't need to do the first 500,000 again, just the next 500,000. So you can kind of split up your workload to handle it in the maximum timeout duration that you get, right? So let's make this take about 8 seconds, this takes 8 seconds, and this takes 8 seconds. If this took longer, well, you just split it up across 4 steps, and now you do a bit less on each step, right? You get the idea, right? Now every step will still remain under that 10-second limit, and you get as many as you want, right? There is no limit on how many steps you want to chain together. You could even map over an array and then have a create function for each of them, right? So that would totally work as well. So you're totally flexible now in how you handle or how many steps you want to handle your logic in, right? That's why this is so beautiful. And let's actually get implementing that logic. So as I told you about, we have the step parameter, right? Which means we now want to read it in the post route right here. And by the way, since this is nothing else than a regular Next.js API route handler, we can also receive the request right here, which is just a standard kind of web request that we get access to. And now let's get access to the path name right here. That's gonna be equal to a new URL, and we're gonna pass in the rec.url, and that's just gonna help us later. We won't need it right now, but the path name is basically like the current path that we're in, like /API/workflow would be our path name for the specific API endpoint. Right, let's just leave this here as an example so you have a better idea of what this path name actually is, right? But more importantly, let's get access to the search params. These come from a new URL, and that's also passed in the rec.url. And now so we know which current step that we're running, 0, 1, 2, and so on, we can simply get the const step is equal to the search params.get, and let's pass the step in here. So if we had any url.com and then question mark step is equal to 0, for example, then this step const right here would be the 0 as a string. However, right, this is not a number, this is going to be a string, so we're going to need to convert it later, but that's how we get access to the search param of which step we are currently on. Great. And now for a quick logic check, let's say const content type is going to be equal to rec.headers.get, and we're going to get the content type header right here because we don't want to answer any requests that are not JSON requests, right? We expect the body of the previous step to be passed as JSON into the next one. And if we don't have a JSON request, well, that just doesn't work. We can't really answer it in that case, you know? So we're going to say if the content type is not equal to application/JSON. There we go. In that case, we just don't want to answer the request. So we're going to say return new response. And in here we can say missing JSON request body, period. And as the status we can send back from here, we can pass that as the object, as the second kind of argument into the response constructor. Right here, we can simply say status is going to be equal to 400, which is an HTTP status for bad request, right? We expect a different method, or you could also do, I guess, 405, which is method not supported. That is all. Yeah, actually, yeah, let's just do that instead. I think that is the better, that's actually the better HTTP status. You know, if we do this, we might as well do it properly. Anyways, if we are past this guard clause, we now know that we are getting an actual JSON request. So we can actually get the body from this request. Let's say let body, and let's default this to any. You're gonna see why right now, because we're gonna do a try catch block right afterwards. Inside of here, let's name the error just error or whatever you prefer. And let's try to assign the body to, and that's going to be equal to await rec.json. The reason we try to do this is because this could fail. And by the way, just really quick, in order to be able to use await, we also want to go to the very top and mark this post handler as asynchronous. So we can do await operations in here, or just in general, async operations in here, right? And the reason we try this is because this could fail, right? If the rec.json body is empty, if nothing is passed in here, right? If I show you the HTTP request to this. So let me show you what this looks like. If we made a post request to HTTP localhost 3000/API/workflow. By the way, don't worry if you don't have this tool or if you can't follow along right now, I'm just showing this to you. You don't need to follow along. Then if we made this request, right, and in the body we didn't pass anything, right? So as the body we specify it's JSON, right? So we are making an application JSON request, but we're not actually putting anything in here. Let's try this. And okay, I mean, our API isn't even running, so we can't really do this. But if it was running and we try this again, then right now we would simply throw an error, right? This would fail because we are trying, yeah, let's take a look at this. Okay, because no response is returned. Well, we're also going to fix that. Don't worry about that. But basically, this is going to fail if the body is empty, but we're still making a JSON request. That is why we're putting this inside of a try catch block. And inside of the catch, we're simply going to assign an empty object to the body, right? So if it's empty, it's still going to be an empty object. So we can proceed in our logic, right? Now, we do have access to this step already. And let's handle the case where the step that we convert to a number, right? Because if you remember from earlier, this is going to be a string if we read it from the URL. If it is larger than this .steps.length, where we save all the steps that the user has created, right, in their route.ts, all of these are going to be in that array. -1, right? So this is kind of 0 based as well. In that case, we're going to return a new response saying all tasks completed successfully. Because if you remember what we do each time we call this API and a step is completed successfully, we increment the step by 1. So at first it's going to be step 0, then it's going to be step 1, step 2, and so on. And if a request to this API is made with a step that is larger than the steps we have defined, right? So let's say we only have 3 steps, right? Let's say we only have 3. And if we now make a request that wants to invoke step 4, well, there is no step 4. So we're going to return early saying, hey, all steps are already done. You're good, right? We are done. All tasks ran successfully. Great. Now, if the step is triple equal to null, so if it is not even defined in the request, which is going to be the case if this is the initial HTTP request made by the user, they're not going to pass explicitly like a step is equal to 0, right? That's not what we want them to do. So in that case, when the step is completely undefined, or in our case null, right? That means this is the initial request to now start the entire workflow. And how do we start the workflow? The goal here is to call upstash, right? The tool that has the automatic retries and backoff and so on all already built in, right? Specifically made for serverless endpoints. And by the way, of course, also like full disclaimer, I work here, right? That's how I can even make these videos. So this is a tool that we have made at work, right? I just want to be fully transparent here. But I also think it's like genuinely like the best tool to do it. But there are other tools that do the same thing. So of course I'm a bit biased towards our tool, but I think it's going to be really nice to use it. Following along, it's just important to me to be like very clear about it. Like, yes, I work here as well, right? So we want to call this tool. All right, there we go. I've just logged into my account. And by the way, if you're wondering where we are, this is Upstash, just the main dashboard. So you can find this under upstash.com, right? That's our website. And when you go to the like kind of QStash section right here, this is where we have the tool that handles all the automatic retries and so on for us. So how we can connect to this tool is really simple. We just have an SDK to do it, right? So to call QStash, that's going to handle, like, I mean, I said this too many times, all the retries and so on, that handles that. Let's clear our screen and let's say bun install or npm install or yarn add pnpm install. It doesn't matter which package manager you use to do this. And we're going to install at upstash/qstash, which is like our API to interact with this tool. And we can simply go ahead and use that at the very top of our core.ts file to connect to QStash. That is going to handle like we just make a request to QStash, and then QStash is going to call each step here separately and make sure it is actually run successfully. So to interact with QStash, we can simply import something called the client at the very top, and that is going to come from upstash/qstash. There we go. Now, of course, when you invoke this workflow class, we do need access to something called the QStash token so we can use it in our workflow, right? If you want more information on what QStash does exactly, we have like the full documentation right here. That's going to be, it's my first time with the Arc browser. It's a bit like, where do I show you the URL? This is, oh, there we go. Like upstash docs, QStash get started and so on. You can read like a bunch of what this tool does. It does messaging. It's a scheduling solution designed for serverless and whatever else my colleagues wrote here. I'm not too sure. But it does a bunch of things, right? And it's going to be really useful to handle like very durable workflows as we want. So to give our workflow access to the QStash client to interact with the tool, we can simply say the client on here is going to be equal to a new client that we can create. And this takes the token, which is nothing else than a process.env.qstash_token. That's what we are going to name it. And let's also put an exclamation point here at the very end to tell TypeScript that this will definitely exist at runtime when we are invoking this class right here. Now, of course, in order for that token to exist, we also need to define it. And I've already done that in a .env file, but you are not going to have that. So let's delete that file and create it together. So at the very core of our project, we're going to create a .env file, just like so. And in here, we're going to define that QStash_token that we just told TypeScript will definitely exist, right? Let's actually make sure it exists. And we can simply grab that token from the QStash tab in the Upstash dashboard under upstash.com, by the way, if I forgot to mention it. And that's going to be right here, the QStash_token that we can simply copy from right here, paste it in here, and bam, that's it, right? We can already exit of the .env file. That's literally all the work we need to do. And now we can actually call our first step in our workflow right here. So to do that, we can simply call the this.client. And there's a method called publish where we can send a message now to Upstash QStash. And this takes a couple of things that we can pass in here, but most of them are optional. The first thing that we want to pass in here is the URL. What is the URL that our tool will actually call? So if we kind of sketch this out, how this works architecturally, because I think that's very interesting to understand. And let's switch into dark mode because this looks absolutely horrible in light mode. Where can we, there we go. So how this works is basically we have our core.ts file right here, core.ts file. And from here, we will now fire the call to QStash. Let's list that here on the right-hand side, QStash, give this a bit more space. There we go, for the first step, right? So we're saying to QStash, hey, in so and so many seconds, in our case, that's going to be 0. So right away, please call the URL, and that's going to be our HTTP localhost 3000/API/workflow with the step of 0, right? That's going to be our first request to QStash to call this API right here. And yeah, this doesn't really look good, but I'm also not a graphic designer, so I hope this is fine. So basically we have our core.ts and we have QStash, and this is the first URL it's gonna call. So qstash right away goes ahead and calls that URL, which basically goes back to our core.ts because this is the workflow class, right? But essentially qstash is just going to call the post method that is exported from our route.ts, right? And where we handle that, well, that is again our workflow with the corresponding step that is then executed right here in the post logic that we have in our workflow, right? This is where we handle the logic of the step that is being executed. Right, and once that step is done, then we fire a second call to qstash, telling it to basically execute the same URL, but for the next step. And if this fails, right, just imagine this fails, anything goes wrong on our end, well, qstash is gonna retry. Those are the retries that I mentioned earlier automatically. And what the hell just happened with the arrows? Anyways, it's gonna retry automatically until this has succeeded with an exponential backoff algorithm, which is really nice because it makes durability so easy. And it will keep calling our endpoint that handles all the logic of the steps that we created until all steps have resolved successfully or something went wrong for like 3 times, right? And then you can handle it manually. That's also possible for you to handle and makes it really easy to define exactly what should happen in this case. And this URL is basically the URL that we want qstash to call, right? So it's gonna be our localhost URL with the step of 0. So that's what we need to pass in here. And to make this as easy as possible for us, we're gonna split this URL into 3 steps. Basically, this first part right here, the whole localhost part, that is gonna be something called the base URL, right? This is gonna be either localhost or it will be wherever we deploy this project, right? For example, on Vercel. Let's go to the very top of our file and define that base URL. Let's say const base URL, so either localhost or Vercel URL that Vercel gives us is going to be equal to, and we're going to do a conditional check. If we have a process.env and we're going to give this a lot more space now, .next public Vercel project production, there we go, URL, right? Super long name. Basically, Vercel will automatically provide this env variable if you deploy to Vercel. If we have this, right, then in that case, our base URL will be that. It's going to be HTTPS because this does not include the HTTPS part. And then dynamically, we're going to insert exactly the same kind of thing right here. So we can just copy and paste it in here. So we're basically just adding the entire HTTPS. And that, of course, also needs to be process.env. And if we don't have that Vercel URL, well, then we are on localhost. So we can simply pass in the HTTP localhost 3000 and work locally, right? Because this is going to work both locally and in production, just the same. Beautiful. So this base URL, we can now simply use way down here as the starting point for our URL. So we're going to implement a template string right here. And the first thing is going to be our base URL. So this red part that I marked for you here. The second thing is going to be the path name, right? So what is the current API endpoint, like /API/workflow? Well, we've already done all the work to know that. If you remember, that's going to be our path name that we got at the very top of the file. And the first thing that we want to do is to call the step of 0 or beginning of the workflow. Beautiful. As the method we're going to use for this, let's choose post. That means qstash is going to make a post request to our API, which is basically what we're expecting, right? And we're just making sure it uses a post request. The headers, we're going to say as the content type, that's going to be application/JSON. So of course, also what we expect. And by the way, these need to be comma separated. There we go. And then as the main body that we're going to pass in here, this is what qstash is going to deliver us as the body in the HTTP request that it makes, right? So this is going to contain the body, for example, and let's set that, whatever qstash will give us to work with, and that's going to be our json.stringify body. So whatever was initially passed into this API route that we parsed right up here. Right, so either the request.json or if that's empty in rare cases, but we are handling that edge case. In that case, it's going to be an empty object that we have to work with for the step 0. Great. Now let's await this call because this is an asynchronous operation. And once we know that qstash has now received or request to call our API for the step 0, we can simply return a new response and say, for example, okay. And by default, the status will be 200. So qstash knows that everything went well and this actually received the call to make the first step, right? Let's wrap this entire thing inside of a try catch block just in case anything goes wrong, and then put this whole stuff in the try part. And in case anything goes wrong, we're saying console.error and simply log out that error. So once we deploy this, for example, or also in local development, in case anything goes wrong, we know what the cause of the problem is and we can fix it, right? Optionally, if you were working on like a very serious enterprise project, you would also log this to Sentry, for example, or any other logging solution that you have to kind of do bulk processing on the errors that you get. But that's just a fun side note. If you were taking this like really seriously in projects like this, normally you don't need to do it unless you have like a large customer base that's using your product, right? Great. Now the problem with this approach, or well, it's not really a problem, right? This works, but it only works as long as the base URL is available publicly. Because QStash is an external service, it literally cannot call you when this is running on localhost, right? QStash does not live in your network. It's an external service. Therefore, if you tried QStash to call if you wanted QStash to call your local host, that really wouldn't work, right? So just in this very specific scenario, because this is the local host version, because we're just running this locally, QStash wouldn't know where to put this call, right? If this was in production, right? If you deployed this API route, now everything would already work and your step 0 would be properly called by QStash, right? But not locally, because that's literally something it cannot do. Therefore, let's also make this work locally. And let's do an if check, right? In our if condition, if the step is null, if the process.env.node_env, which is a built-in environment variable in the Node.js runtime, if that is equal to development, that's simply what we can check. This will always be provided in Node.js, which is really useful, right? So if we are in development, let's simply invoke our function, right? This is nothing else than a function, so we can simply invoke it. Let's say fetch, and we're going to fetch basically the same URL, right? We're just going to copy this over, same thing as we call for QStash. And now as the method, we're going to pass a post, and basically all the rest is going to be the same. We can just copy and paste that over, right? So the only difference is we are fetching the API route ourselves instead of using an external service. But in local and in production, the behavior is going to be the exact same, with the only difference that in production, we're actually going to have like the retry mechanism with backoff and so on, whereas in development, we're just using the regular fetch to do it. And once we fetch, we can simply return a new response and say, okay, right, in this case as well. Beautiful. And just like that, we also make this work locally, right? So if we save this, let's see what already happens. Let's make sure we start our development server, and let's actually call our API endpoint. You can do this via curl. You can do this via any HTTP client like I have here. And why is it, bro, just there we go. Okay, via any HTTP client, it doesn't really matter. Let's zoom out a bit here and let's call our localhost and see what happens. Let's call it. And okay, we get an error. What's the problem? No response is returned from route handler. Where did we forget to return something? So right now below the if statement, right? So we're checking if the step is equal to null. And if it's not, right? If we have step 0, basically what we're trying to fetch, well, we're not processing that yet, right? So let's return a new response saying okay for now. And because once we call this for the first step, we're not actually executing the logic just yet. We're just making sure that we can call this to process the first step. All right, so let's try this again. This should work now. Let's call this beautiful post API workflow, and that calls the same API, but with a different parameter in the URL, which is now our step 0. And after the step 0, that's going to be step 1 and so on, as long as we handle that case now, right? So in the other case, in the else case, right? So if we kind of collapse this, you're going to see a bit better what's going on here. Let's collapse this. If the step is equal to null, we're going to handle the case that calls our API with a step 0 parameter. And else, if the step is not null, this means we now need to execute the logic for the step that is being called on our API, like step 0, step 1, and step 2. That is what we want to execute now in this else statement if the step is defined. right? So let's handle that logic. And trust me, this is much simpler than you think it is. First off, let's grab the actual action that the user wants to execute for this step. So let's say const action is equal to this.steps, where all the different steps are saved that the user wants to make, right? 1, 2, and 3 in our case. And we're gonna grab the steps at the index of number step. So if we have a step is equal to 0 passed as a query parameter here, we're gonna get the first item in the array at the index of 0 because arrays are 0 based, right? And that's gonna be the first step, the first function defined right here. So whatever logic is in here will now be saved as the action, which is nothing else than a function, right? And we can simply execute it. Let's say const res is equal to await action, and we can simply now invoke the action that the user defined with the body that we got in this request, right? That is how we pass along the return values of the previous function into the next function. That is actually just the HTTP body that is sent along with each request, right? As easy as that. Now, we are done executing step 0, right? We have executed the function that the user defined for step 0. So let's call step 1, of course, so the next step in the flow. But we're only gonna do that, we're only gonna call the next step if there is a next step, right? So let's check if there is a next step. If number step is smaller than this.steps.length minus 1, there we go. Only in that case is there actually a next step, right? If this condition fails, then we are already at the last step. We don't need to fire a call for the next one. But in this case, there is a next step. There is a step 1 in our case. So we're going to say await this.client.publish. And basically, we can do the same logic as before, right? So if we expand the try block again here, we can simply copy all the logic of the client publish, what we're calling qstash with, paste it in here and simply increment the step by 1, right? Because now we want to call the next step, but still with the body, right? So that's going to be the output of each different function. So for the step, we're going to turn that into something dynamic, and we're simply going to say number step plus 1. So we're simply incrementing the current step that we're calling qstash to execute with, right? So if you take a look at what this looks like conceptually, let's open this up. We are now done with step 1, right? In this case, let's say now comes, or yeah, I guess step 0, right? Because it's 0 base. Now comes step 1 that we're calling qstash right here. With, right? So it calls our API endpoint with all the body data that we attach to the request. So that's going to be the post request body. That's why we made this a post request, right? And as easy as that, we can call qstash to call our next step. Beautiful. Let's grab the entire code that is in our else statement and simply wrap it inside of a try catch, where we catch the error. Let's do that in the try block, and also return a new response saying, okay, if everything was successful in the try block. And in the catch block, we can now handle this error. And for example, one thing I always do is say console.error. So we get the error in the runtime logs, and then also return a new response. And in here, let's say workflow error. And now very important, because the status by default is going to be like a 200 status. As the status, we need to pass an error code, like 500, for example, to indicate to qstash that, hey, something went wrong. You need to retry this, okay? To automatically retry this a couple of times with the backoff strategy that we pass to it. Beautiful. And now let's cut this entire try block, because we're gonna do one more thing, and that's checking if we're in development, right? Because we also want this to work in development, of course. So I can literally show you that this works right now. So let's say if process.env.node.env, same logic as before, right, is development. In that case, something is gonna happen. And in the other case, we are in production, and that's where we're gonna paste back in our try block that we have, right, with the entire logic. Oh, and by the way, one thing I just noticed, the res, the return value of the action.body, that is gonna be what we pass into qstash, right? That's how we get the recursive passing as the output to the input to the input, and so on, because we're always passing the return value of the current function along to qstash to call the next step with, right? That's how we achieve that effect. Let's get rid of the example. And now let's quickly handle the development case. That's going to be really, really easy. We can basically still, right, invoke the user action. That's going to be the exact same thing. And the only thing that changes is now instead of qstash, we're going to do the same thing with our fetch API. And we can simply also copy that from way up here. All right, so same thing, and let's zoom out. This is just zoomed in way too much. I hope you can see even when I'm not zoomed in that much. There we go. And let's paste that in here. So instead of qstash, we're simply using our basic fetch API and then return a new response saying something like, okay, everything went wrong. Beautiful. Let's save all of this. By the way, of course, all the code here is also going to be accessible as a gist on GitHub in case you got lost anywhere. And let's try if this works. Let's stop our development server, clear the screen and start it again. I don't know. I just kind of like to do that. And let's actually call our API. And what we expect to happen now is that first it invokes the API route without any step. That schedules the calling of the first step. And then the first step will trigger the second step and so on. Oh, and by the way, one thing we forgot to do is to also pass the res body in or fetch, because essentially all we're doing is basically, now let's do this properly. Let's copy the entire block of our production kind of step and paste it in our development step, and now simply replace this middle part. So the only thing we're going to change is how the HTTP request is handled and not any of the underlying logic. Yeah, I think this is just a much better approach to do it. So let's now copy down the fetch inside of this if check. There we go. So that's what we didn't have before. Now we have it. And we simply also want to increment the step right here that is called to invoke the next step and pass the actual return value of the user function into our body. So what we expect to happen now is for each step that we have right here, we're going to go through sequentially step 0, step 1, and so on until we're done. This should already work. So let's try it together. Let's invoke our API endpoint and let's see what happens. We have step 0, step 1, and step 2, and all have resolved successfully. Beautiful. Let's try that again because I didn't have the console open. Bam, click this, and all steps are executed one after another. And we can make even more clear that this works by simply having a timeout in here. So let's say, for example, in the first function, in the first step that we define here, let's say await a new promise. In here, we get access to the resolve function, and we're simply gonna delay the resolve by using a set timeout. So the set timeout, it gets the resolve function, and then when we want to resolve, for example, after 6 seconds, right? And then we can simply copy and paste that into all the steps that we have right here, right? And once we save that, we now expect each step to take much longer. That's 6 seconds. Let's try that out. Let's invoke our HTTP workflow. That's gonna call the first one. Bam, that scheduled the first step. We should see 6 seconds later, there we are, that the first step is successful. Now comes the second step, right? That's also gonna take 6 seconds. There we go. Second step is completed, and now comes the last one that we're gonna have. There we go. Step 2 is completed as well after 6 seconds and 13 milliseconds, which I guess is the overhead of the actual function, which is not a lot, to be honest. And our entire workflow works beautifully. Dude, awesome. Let's verify that this works in production by actually quickly deploying this together to Vercel. And then we should see that we can now by far exceed the Vercel timeouts, right? Because this in total now takes 6, 12, 18 seconds, right? That's way longer than the standard Vercel timeout. So normally this would fail, right? But in our implementation, this should work. So let's try this out together. Let's deploy it to Vercel. Let's add everything in here to Git. Let's simply commit by saying, I don't know, commit. It doesn't matter what we put in here. And then let's also create, I've opened up my GitHub right here on the right hand side. Let's create a new repository for this. I'm going to call this workflow-test as a private repository, and then simply hit create repository. This is what we're going to deploy to Vercel. Great. We can simply copy the origin in here and simply use that command in our console. Oops, I did a little typo there. Paste that in, and oh, I already have a remote origin because I already deployed this, but I want to deploy together with you, right? So let's say git remote remove origin. There we go. You don't have to do that if this is a new project for you, but I want to deploy this together with you. I want to show you every step of the way. So let's add our new GitHub repo to here and simply say git push -u for upstream origin main, and then hit enter. That's gonna commit or push rather our entire project to the main branch in our GitHub. Let's view it. Let's refresh our page, and we're gonna see all of our project files here. That's gonna be your Next.js project in the source directory. you can have your app API, and I already have a couple of examples here, but what we just implemented together right here is the workflow API route, right? And the important thing is that we have it because now we can deploy that to Vercel. Let's try it. Let's create a new project in Vercel that's automatically going to offer us all of our GitHub repos, and I'm gonna choose the workflow-test right here, hit import, and then as the environment variable that we want to set before we deploy, that's simply going to be or.env or qstash token. Let's grab everything in our .env file, simply head back over to Vercel, paste it right here in the environment variables, and then we can hit deploy and see what happens. Hopefully no build error. And once this is live, we should be able to see that now we can by far exceed the Vercel timeouts and have a much more robust workflow at the same time with automatic retries, right? So if you wanted to, you could even have like a random chance that you implement right here to throw a new error, like 25% chance, right? If math.random is smaller than 0.25, in that case, you're gonna throw any error. And let's invoke that. There we go. If you wanted, you could do something like this. I didn't. I just want to show you that this works. But that would demonstrate how the automatic retries work in your function as well. Anyways, let's wait for our deployment to finish. And that looks very, very good. No build errors. That's exactly what we want. And once that's done, it's going to give us a URL that we can actually call on the internet and then view our logs, right? Perfect. Okay, so that deployed our project. So to view if everything works, let's go into our runtime logs and actually call this. Oh, by the way, what was the URL that Vercel gives us? Right here under the domains, let's zoom in a bit. This is the domain that Vercel gives us for this deployment. And let's simply call that domain /API/workflow and also navigate into runtime logs to see what happens. So let's hit the arrow. That's going to give us an OK. And by the way, I don't think we logged anything here, but we should see the HTTP request come in. There we go, API/workflow. And we can also see the status of everything here in our upstash dashboard. I'm gonna log into my upstash dashboard. We should see in qstash right here under the logs as well, or workflow, right? So we can see that the step 0 was called, step 1 was called, step 2 was called 11 seconds ago, and everything worked exactly as we expected to. That is beautiful. Now, just to make really sure, let's also kind of log something out in each step that we have. Let's say step 1, and then also let's say at the very bottom, step 1 completed. And let's do the same thing for step 2, just so we can see in the runtime logs that, hey, everything actually works. So let's say step 2 completed, and for the last one, step 3 and step 3 completed. And we can also log out the input, I guess, in step 3, because this is normally gonna be the step where you save something to your database, which is the result of all the prior steps that you get access to right here. And fully type save as the input, right, where we have the name. Okay, with those changes in place, let's also add them to Git. Let's commit them with a commit of, I don't know, it doesn't matter. And let's push them up to remote as well. That's automatically going to trigger a rebuild on Vercel for us. We can see that under deployments, Vercel has seen that something has changed in our GitHub repository, and it will now build that project for us. And once that's done, let's do the same thing again. And then we should see in our runtime logs the different steps that run and how they complete successfully. So let's give this a second, and I'm gonna be right back when this project is done building. There we go, the project is done building. So let's head over to our runtime logs and let's see what happens here. Let's make an HTTP request to our endpoint /API/workflow. Bam, that's gonna create the first request. And then let's see what happens. We should see our runtime logs pop up right here with the like step 1 and step 2 and so on. So let's try it. Okay, so we get a message step 1. In a couple of seconds, we should see that step 1 is now completed. So let's give this a second. We got new logs. There we go. Step 1 completed beautifully after 6 seconds, right? It takes that long. Then 6 seconds later, we should see that step 2 is now completed. Let's view the new logs. Perfect. And we also have step 3 and step 3 completed as well. Now, what do we see? Everything worked amazing. And also everything worked even because even when it far exceeded the actual 10 seconds kind of maximum that we have on Vercel, right? This ran for about 20 seconds and it worked perfectly fine, right? That's the beautiful thing. Not only do we have like the really robust retries and so on, but also we can run this basically for as long as we want by creating as many steps as we want, each one now having that 10 seconds limit, and we can basically split up our work to match that limit for each step. And I think that is just amazing. All right, dude, that's basically it. I love this API. I really like how this works with full type safety and so on. I guess I kind of over-engineered it, but it's also just really fun to build. And look at this API. Like, that's our Next.js endpoint now. How cool is that? I really like this. It worked. We know it works. And yeah, dude, good job following along. I really appreciate you following along. And I hope you're going to have a lot of fun with this implementation because it's just really nice to work with. So I'm going to do the outro in person. And yeah, thanks for following along.